Okay, we are Western Automation, and this is the 7 a.m. Monday morning training class, first one of 2025. Welcome to the new year. And today we have Chad Christopher presenting on machine safety and the associated products that we represent to support these applications. Machine safety is an interesting market in the United States. There's a lot of business going on in the United States, but we are not as consistent in, shall we say, enforcing machine safety standards as they are in Europe. And therefore, it makes the market very interesting in terms of customers that are sort of navigating the fine line between full compliance and what they can get away with. So I'll leave Chad to comment further on that. And with no further ado, Chad, thank you very much for presenting today.
Thank you, Pierce. Happy New Year, everybody. Welcome back to the grind. This is going to be a long week. So today, as Pierce spelled out, we're going to do a little safety overview. One of the things I'm going to focus on here, some basic safety principles, just kind of, the real background of what's going on, but really innovations and newer ways of doing safety layouts. It is a space that continues to get much better in terms of deployment, diagnostics, really just with the various other types of devices, you see where they've adopted safe torque offs or safety valving or other types of, upper tier products that are designed to go in this space. So, as usual, if there's any questions, please feel free to interrupt and ask them. If you could keep an eye on the chat too, Pierce, that'd be great if there's anything there. And without further ado, we will get going. So what is safety? I think everybody's been around here long enough to know what's going on. And really, it's I guess in the most cynical way, it's trying to prevent lawsuits, but in the most useful way, it's trying to actually have a good work environment and a safe spot. There was a safety specialist years ago at Banner that had a good way of putting it, and I've always liked this and stolen it from him. A good safe design machine would be one that you would let a group of Cub Scouts, loose in the factory and don't worry about them hurting themselves when they get around that machine. That's a well-designed safety system. Maybe not always completely capable to do that, but it's a good way to start thinking about it. One of the other, I guess, bad jokes I like is that, well, ultimately this picture is pretty correct, especially if you drop off the last line. There's no such thing as a 100% safe machine. The only real safe machine, 100% safe machine, is one that's in a crate, in the warehouse. There's always something there that is, if it's moving on its own, it is inherently capable of causing an injury. So again, goals: reduce reduce injuries, reduce costs, comply to standards. Those are the high-level goals, and like Pierce said, it's really more about what vendors or customers do to see what they can get away with. OSHA is the government's authority of who can actually enforce the laws, and by enforce basically means fine. But they don't write any of the standards. OSHA refers to ANSI standards largely here, and you're starting to see a lot of harmonized standards between the US and Europe, whereas the concepts translate back and forth, where years ago, when I started out in this space, there was zero interaction between what would be considered European standards and US standards. All right, blah, blah, blah. If you've been around for a long time, you may have heard the phrase control reliability. That is what is called out in the OSHA standard for fails in a safe condition. A common phrase I've heard in safety over the years, which is just somebody not quite understanding what they're saying, is fail safe. That is not what safety is. It's a fail to safe, which means it can fail, and they do fail, but they will stop the machine from operating. So this is one, again, for folks who've been around for a while, a nice slide because it pulls together a bit of the old terminology we hear thrown around and the newer ways of doing things, and the two items that really go together to spell out your actual safety system. So years back in the US, you would have heard the phrase Category 4. These were the older ways of describing things. A Category 4 was a control reliable circuit, which meant it was a fail to safe circuit and had the appropriate hardware to achieve that end. Um, Over the years, and I'll dive into this a little bit further here as we go on, this has migrated into a much more concise and useful, I'd say, way of doing things. It now is a combination of a safety integrity level, or SIL, and a performance level. These are uh, very different things, but they definitely go together. If you can you see the, let me do this and I know it works. Get a laser pointer here. This little diagram is terribly useful. So SIL levels, I really think of a SIL level as basically an MTBF. It is a design requirement for what the inherent likelihood or recurrence of a failure would be in a system. Whereas the protection level is the design and implementation of the system kind of as a whole. I've got some more information coming up, and I think we'll maybe shed a little bit more light on that. In terms of doing this from the banner standpoint, if we're looking at the calendar or calendar catalogs and things like this, under every one of our segments, depending on whatever device it is, there's going to be the um, applicable standards and ratings shown here. These are printed on the side of the safety devices. It's pretty straightforward there, but you can see here in terms of light curtains, we're mentioning a type 4, which is a different thing. That is a design of safety light curtains specifically. Type 4 is the highest safety level. Years ago, there were type 2, which were basically a single channel type light curtain. They were significantly less expensive. As time has gone on, type 4 curtains, the pricing has dropped so dramatically that there's almost no reason to even consider using a type 2 curtain anymore. But as you can see here, though, under the safety rating, so this is basically saying this is capable of meeting Category 4 protection level E. It's a SIL 3 device per this ISO standard, and then effectively the harmonized IEC standards, it's a SIL 3 device there again. So how do you end up at the protection levels you're looking for? And that all comes out of risk assessment. Risk assessment was not a thing in the US 25 years ago. And it has made its way here. This is the way Europe's been doing it for really ever. But on the back end, Europe had a very different legal structure and effectively a menu of compensation for an injury. So if you lost part of your finger, that was this many euros, and there was no lawsuits or anything to that effect. It was, this is what it is. So a very different scene than it was here. So risk assessment is really the way of just breaking down what the machine is doing and then determining, how to prevent or minimize those issues.
Hey, so
So
Chad,
yeah,
may I
yeah.
interrupt 1 second? I just wanted to mention something that's important for the distributors. There is case law in the United States that confirms the fact that if a distributor sells a safety part, to a customer they cannot be held liable for how the part is used and any resultant injuries. So that's very important for distributors to know in terms of assessing their risk in this market. You can sell parts and not be drawn into lawsuits um, for the most part in terms of U.S. case law.
Hey, Pierce, just to
Yes.
maybe qualify that a little bit, selling parts versus we suggested the thing. And we're a bit cautious. You know, if a customer has XYZ brand light curtain, for example, as long as we know the specs are one for one identical, then saying this is an alternative to that is fine. But if we're suggesting the system, and that's why typically we don't suggest the system unless the customer has worked with us to do a risk assessment on the machine. And we tend to work through a safety integrator to get that stuff done.
Yes, thank you. That's a very important clarification. Once you cross the boundary into an advisory mode, then you do assume a little bit of risk or a lot of risk, depending on what the situation is.
Has there been any movement, and not to go off on a tangent, Chad, but it historically the employer has been responsible for protecting his employees or their employees. But I know there was some discussion a few years ago with RIA and some of the other organizations about expanding that to include the integrators that specify these systems and things like that in that overall liability process.
Yeah, I don't have any specifics on there where a third party integrator, would be specific in the litigation cycle, but it would be those types of companies, they should be set up in such a way that they have specific liability agreements with the customers ahead of time. Of course,
Right.
here if somebody
Yep.
gets hurt, they're going to sue everybody anyway. But
Yeah.
it does also go back to the other end of this, which goes way back, which actually started kind of getting some of this stuff moving years ago. It was always the employer's responsibility. So effectively, a machine builder could build a death trap, send it to a customer, and now it's the customer's problem. And years ago, there was a specific company, I think you know the story, Dan, that was building scissor lifts. They had a European version and a US version. European version had all the safety on it. US version didn't. The guy got severely injured on the US version, and they successfully sued, basically saying, well, the machine builder knew this was dangerous and chose not to put safeguards on it.
Yeah, absolutely.
So this discussion is never any fun, but we try to. Yeah, I've been doing these a long time too, and we try to really do an educational role, answer questions, and give right up to the point of do this. I think customers have become much more comfortable with safeguarding than they were 15, 20 years ago. Then it was always viewed as just an added expense. What are we doing this for? All right, continuing on. There's methodologies here. I've had this question many times. Well, is there a form I can go get to figure out how to do a risk assessment? Short answer, yes. Short answer, no. There's ways and guidelines on how to do it. You can buy software. There's various things out there to do, but there's not really an easy button per se. You can hire integrators and third parties to do these types of things and write reports. Some of our competition sort of does that. Um, I've seen many of these reports. I've had them from various vendors over the years, and to say they're certainly not worth the money they're spending is probably an understatement. They still keep it very baseline, and it ultimately still is going to come down to the owner of the machine, the employer, ultimately responsible for getting everything set up. Um, Running through this basic format for risk assessment, and just the only reason I'm doing this is just to kind of have in thoughts. If you're looking for safety, if somebody's asking you, for any sort of safety help on a system, these are the things we're looking for. The things I'm looking for, of course, which is can you design out hazards? Can you do torque limiting? Can you do, gap mitigation in such a way that, well, somebody can't actually get their hand in there. There's no reason to get in there. Things like that, reducing velocity, just various ergonomics and basic things, and even improving lighting. I mean, that's a big area where Banner's got a huge lighting offering, where if the operator is able to see what they're doing a lot better, they may be able to mitigate some of these other instances. So what the designer kind of moves on to is safeguarding and complementary protective measures. A couple interesting things here. I don't love this because two-hand controls are not a safeguard per se. They are a initiation device, safety light curtains, interlocks, laser scanners, floor mats, that type of stuff. Those are really the safeguarding devices because they operate without anybody's specific input to make the system work. Whereas an e-stop, a two-hand control, a rope pull, something like that requires an active event from an operator to trigger the instance. So, same, really not a whole lot of difference though, really just from kind of your standard machine design. It's, risk assessment bakes down to, what's the machine doing? How does it work? Where do we go from there? Who really should be involved with doing these? Well, machine builders, I think, are getting pretty good at this and understanding that they do have a liability. So they're addressing a lot of these things and at least sending machines out with a base level of safety. But ultimately, it still comes down to the user's responsibility. These things should involve kind of the people, in terms of building the machine, maintaining the machine, but then also operating the machine. Nobody knows the better ways to either cheat a system or do something silly with the machine than the operator that's standing there for many hours a day running it. I've seen some terrifying machines over the years watching operators who have jerry-rigged it to do certain things. You're just like, I've asked customers walking through plants, listen, if I see something, do you want me to tell you or not? And I've gotten various answers to that. So these are basic questions we're looking for. These are just the basic ins and outs again of what's going on. One thing that is key that really is no longer an option in older safety standards, you could grandfather in old machines. So you could have basically two machines doing the same thing next to each other. If one was older, it only had to meet the applicable safety standards at the time it was built. That is no longer a thing. They basically have to meet the current standards. All right, jump ahead here. So these are just the three things to keep in mind for all risk assessments. There are many in different industries risk assessments. They all fall down to these three items: severity, exposure, avoidance. They'll use different names for them. They'll use different code numbers. But severity, in my dark humor way, I always say, will it grow back? Severity is it serious, irreversible, fatality, more than first aid? A slight injury, S1 in this case, is a bump, bruise, maybe a burn or something like that. But yeah, simple on-site first aid. Exposure. Um, how often is the person there? If it's a hand-loaded punch press, their hands are in that machine every 2 to 10 seconds. Maybe they also watch their team choke the night before. They're not paying attention, and they're basically running on autopilot at that point. It's much more dangerous than if it's a once a shift maintenance issue where they got to go in and add some material to the machine. Where even then people get, I guess, laxed in their paying attention to what they're doing, but on a much less frequent exposure, they are much more likely to still be paying attention. And then avoidance. Everybody here does motion control, pneumatics, things of that nature. You know how fast it is on initiation. A pneumatic valve going, or a linear servo, or a actuator firing. Those things are covering a foot very quickly. Your typical real good reaction from somebody, I mean, that's really paying attention, is probably 0.3 seconds, something like that. Any of these devices can cover a lot of ground in 0.3 seconds. So what do these boil down to? Well, this is the older ISO standard, that category 4 control reliable. And one of the first risk assessment standards here in the US was ANSI RIA 1506. That was the old robotic standard. And it really was how these were breaking down, but what we see here using the robotics and these numbers I'm using, how this breaks out. But what I'm going to jump ahead here to is basically how this has moved to the modern level using performance levels, and then how the SIL level kind of sits on top of this. So here's what we really are looking at. This is the current ISO standard of how things are done. And what you can easily see here just by looking down the flow chart is severity, frequency, and possibility of avoiding the hazard. So if you're in the wrong place and the machine operates, can you get out of the way? So severity, of course, is the dictating factor, and frequency. If it's a fairly high force reciprocating, servo or pneumatic press, where a digit or a hand or a limb's coming off, you're in an S2, that's a high severity level. The frequency is high, and the probability of avoidance is extremely low. So you can see as you go right down the flow line here to a PLE safety level, the PLE is the highest level safety in the current standard systems. Unfortunately, I don't know what they were thinking when they laid this out, but what you also see, a fairly common one, is maybe a less severe event, non-irreversible, but it's still frequent, and you don't have much of a chance to get out of the way. So say this was a light-duty pneumatic press, servo with good torque limiting, something to that effect. Now you're in a PLC safety level, which has nothing to do with a programmable logic controller. And I'd like to smack the person that came up with using PLC as part of the safety nomenclature. But anyway, SIL level, again, sits on top of all of this. So you can basically see it's I can't remember what PFH stands for, but it's basically the likelihood of an event per hour. And they're just multiples of 10 effectively going up. So a performance level E device is going to be in the highest type safety level. This is all part and parcel of that SIL that sits on top of this. So really the only two things you're going to see is a PLE or a PLC safety installation. Anything below that, where it's a low severity, and even if it's a decent frequency, and you have a very good probability of getting out of the way, at that point, a PLB level is effectively, stickers, a simple piece of plexiglass that maybe isn't interlocked, things like that. So it's a very simple installation versus the higher level systems. So jumping ahead, I'm showing you this so I can show you how not to do this anymore. But really the old fashioned way of doing safety, if you go back far enough, this is your basic circuit, right? I hit the start button. I have a contact that latches around once this is running. Close my contactor, switch my three-phase to my motor, off we go. Big inrush, all the normal problems that Pierce has covered ad nauseum with starting across the line. And if you want to stop this, well, you hit the stop button and you say a little prayer, because if, say, your hand or your shirt's getting pulled into this motor, that this contact block works. There's nothing shorted. All the contacts here open when we actually de-energize. And this is purely a basic circuit. This is a single control line with zero redundancy. This would be slightly better, whereas now we're in a single channel quote unquote safety circuit. This would be the old like Cat 1. This would be the kind of PLA, PLB type level, where this device will break this contact open because it is a force guided device. It will wedge actually a device through to bust this. So even if this is welded, if somebody actually activates C-stop, it will break the contact open. But that doesn't guarantee that one of the phases on the contactor isn't welded. So you may get two phases off, but you still may have one phase. So still applying some power to the motor. But this is still an extremely common circuit. We start, I hit myself one there, I think. So now we start getting into a little bit better ways of doing things. Now we're talking hardwired. This would be e-stop circuits into a monitoring device. We're doing redundant contactors such that we're killing power to both of them. And we're actually monitoring the contacts to make sure that these, which are all now mechanically linked, did in fact open. If one of them didn't, of the two, we should still kill the motor. And the safety relay will be smart enough to realize, hey, that contactor didn't open when I told it to. Do not let the system reset. We still have some shorting issues, like if we lost a connection here between the C stop and had some of these elements were basically left out of the link. If you hit one and it didn't operate, and then you went and hit the other button and opened it back or closed it again, that would allow the system to reset. So that's why this is just single channel monitoring, your basic circuit. Gate switches, really the same concept. This is still single channel monitoring. This is also extremely common, but there's much better ways to do this. We can get you a less expensive way to guard a system with daisy chained safety hardware now that makes all of this irrelevant and much easier to actually implement. This is better. So now we're into dual circuits on all the interlocks, but we still have failure modes of a single device. This mechanical item can fail. The key could be broken, and there's no way to detect that. So even by adding the dual channel here, we still have all the rest of the stuff. We're still only in a single channel because there's a single fault mode that could cause this to not operate. Now we moved up to dual channel with monitoring. This is considered a control reliable, even though we're going single circuit and daisy chaining these switches, because we have redundancies throughout the system. I think probably you would get people that if they go to the old standards arguing this is Cat 3 or 4, but this was definitely better than the previous slide and kind of the way it's been done for a long time for people that were guarding machines and more appropriately. Then you saw the advent of magnetic switches. Magnetic switches have different failure modes than the mechanicals, like on the previous slide. So you can get by with either daisy chaining them or maybe having a single switch per door. Not in all instances, depending on this type of switch, but it allowed some more flexibility and kind of a non-contact, no mechanical precision alignment required. This has been also, now there's new devices, new hardware that makes this also kind of obsolete and easier to deploy. This would really be the top level, what I'm going to say, the old fashioned way of doing safety stuff, which would be 2 switches per door on a individual monitoring safety relay per door. This is category 4 PLE, highest level of safety. There is no single fault that can occur here that would prevent the system from shutting down in the event that it's actuated. But expensive, a real pain to wire. It's one of the reasons you've seen now over the years the programmable safety controllers become so popular. Light curtain safety distance, I'm not gonna really spend any time on this. This is just how far back you can mount your safety devices. It's a very specific formula. This is also effectively universal. This is the US version. But it is a good way to just think real quick. I mentioned how quickly people can react to things. OSHA says, the typical fastest somebody's going to move their hand is 63 inches per second. If you figure your safety system takes half a second to stop the machine, remove the hazard completely, say half a second, which sounds fast. Just divide, literally, you can throw this whole equation away. Divide 63 by 0.5. That means your safety event needs to start 31 inches away from the hazard, around 31 and a half. 32 would be better. So it does really dictate that doing proper safety systems isn't just eyeballing where I'm going to put my stuff. So Banner's got, a whole family of your, I would say, kind of traditional safety devices. And what we're starting to see, and what I'll cover here with our remaining time, is a lot more of what is a distributed or a wiring optimization way of doing things. You can see here, we don't even really show the old red safety controller or safety modules on these types of things anymore because there's really no point in using them. They're single function and they're just as expensive as in most cases now as programmable devices that give you way more flexibility. So we've got our light curtains, our light duty stuff, laser scanners, e-stops, touch buttons, magnetic switches, RFID switches, integral hinge safety interlocks, locking solenoids. Again, your standard suite of goodies. And here's a real typical cell. There's a lot of beauty in the way that we can also interface it with the devices, the end devices now, which is utilizing safe torque off, which now is on pretty much every type of robot, every type of motion controller, and VFDs. It's a standard input. And for folks that maybe aren't quite sure what safe torque off is, um, this was your old-fashioned way of dealing with a drive or a soft starter or anything else to start the machine. Yeah, we had probably didn't even have a safety relay. Maybe we had a safety relay, a stop button or start button, and then a safety contactor on the up feed side and the downstream side to kill power to the drive and kill power from the drive out to the load. Really, that is again the old-fashioned way of doing it. Now all of these types of controllers have integrated safe torque off, which is usually a dual channel input. And either we're taking two OSSDs, which is your standard safety 24-volt output, directly into those terminals on the drive, or you're even seeing a higher level of safety control built right into the devices. And that just becomes, part and parcel of the evolution on the systems. In terms of like Yaskawa for us, Pierce, you could comment. I don't think there's a single drive we have other than the old stuff that wouldn't have safe torque off in it by default.
To a SIL 3 level, as a matter of fact.
Yeah. Yeah, the safe torque off circuit is effectively the same as like a light curtain output or something to that effect. So it's at that SIL 3 PLE level safety. All right. All right, so back to, I said the whole universe of things. Grid type light curtains, where you're trying to just detect bodies and allowing parts to move through the system using a terminology called muting. We support all of that. Regular resolution light curtains here to protect a hand. You've got a laser scanner, which would be considering this the safe space and this the warning space. This is definitely a little bit of a marketing document because I don't know why you'd put that there, and also light curtains, but hey, each their own. Indication for what's going on with the system, safety controllers here in the control panel. Yeah, just your standard cell. Everybody's seen one of these anytime they've walked into a factory, especially with the continuation of the robots being deployed everywhere. So again, the family of goodies we have. One of the things I want to jump through to then is the ISD, which is a better way of being able to deploy your typical safety interlock, e-stops, and things of that nature. Sorry, through, I know it's here somewhere. There we go. ISD, so in-series diagnostics. This is unique to Banner. There's some other vendors out there that had some similar type products. This is a very nice solution because it allows us to get back to that PLE, SIL level 3, Cat 4 safety layout with the simplicity of really an IO-Link type layout or a very basic communication bus. So what we're able to do with the in-series diagnostic stuff is take these devices, and I'll go a little bit more into this, and set out a daisy chain where we're all connecting them through 4 and 8 wire M12 connections. We have a whole layout to do this and have them communicate over that bus back to the local safety controller and then be able to control that machine. So instead of doing all the hardwiring I was showing on earlier slides, this is literally plug and play. And you tell the controller, hey, I've got e-stops, I've got interlocks, I can mix and match. The limitation is if one thing on this string is hit, that shuts down that whole string. So on our smaller SC10 safety controller, we do 2 strings. On our bigger SC26 or XS26, we do 8 strings, and we have an add-on ISD module. So you can do 32 devices on one of these strings. So it gives you the ability to really simplify all the wiring on a system and get higher order diagnostics. So like on the RFID switches here, we can tell internal temperatures. We can even tell the gap distance between the sensors. So you could be using that for preventative maintenance to say, hey, these doors are starting to get out of alignment, something to that effect, and just give you much more visibility. Our controllers are networkable. We do not quite have the ability to have this controller turn off stuff on this controller over the network. That's coming, should be this year. And you're going to see that ability for all of these devices and systems to interact better with each other now. We do have a network neighborhood capability in the software to view a bunch of these on the same bus, but can't quite do all the safety handshaking as yet. Yeah, so these are the type of devices supported. This little T allows us to add all kinds of different things that aren't just native with what we're doing. Safety controller, and then of course we are multi-protocol network out. We do have an EtherCAT slice for the bigger controllers too, but that is purely a monitoring communications. It is not like a EtherCAT safety interface. So a little bit closer view of what's going on here. This is the SC10 controller. So we have 2 relay banks built into this, so we can switch AC or DC, 6 amps. And so we don't do solid state outputs out of here. Whereas the bigger version, it is solid states with add-on relay packs if need be. We also do just simple little interface relay devices that allow you to switch AC loads. So what you see in laying this type of thing out is literally we just pick our devices, whether we need a local reset for the device or it would be reset by the control. And then we can use the T's to add on mechanical interlocks, locking solenoids, really other types of devices. We cannot run light curtains on this ISD Connect device. It just doesn't have enough current. But there is a lot of other types of devices, could be rope pull, could be other things like that that we can interface here. We also have all our illuminated e-stops, base mount, flat mounts. Plus, we have panel mount e-stops available, which are really just pre-connectorized to use the ISD Connect, or you could use third-party devices that are any mechanical contact. Yeah, so just a couple little indications of what we're looking at here. I want to jump over to, for the folks that haven't seen this or would be interested, we have an ISD page on the Banner site, and I can tell you, I don't know, we probably had this out now for, I don't know, 5, 6 years, something like that. Last 5 years get a little blurry, but there's a nice little video on it and everything. But one of the things we finally got out that is fantastic, and Banner's gotten good at doing this on a couple of different things, which is build a little bundle. So you could actually build out and say, okay, I want one of these controllers. I'm going to do 2 ISD strings. And what we're trying to do is walk you through graphically everything that's kind of going on here. So I'm going to say, I'm going to do 2 strings. That's my bundle. I can go to my devices and say, okay, I'm going to do RFID switches on one string and e-stops on the other one. And I like the illuminated base mounts. I'll grab 3 of those. And it's even telling me, well, you're probably going to want T's for that. So I'm going to add my T's I require. I'm going to add some ISD interlocks with a lower safety level. So I add those. Again, it's going to say, well, you probably need the mating actuator, and you're going to need some more T's. I've already got the safety controller. And then we give you the selection choice to add in, as soon as the page loads, your interconnecting cabling. And we're telling you which ones to use. So you just pick those, and I'll just pick some of these for the sake of being quick. And we're done. We've got our bundle of goodies. We can export this as a parts list, add it to your library. You could send it in to the Inside Apps guys at Banner. If you said, hey, am I missing anything or want to look at that? So we've made it super simple to pick out a system here and get everything you need to do an ISD bundle. So great product, very useful. The RFID switches, the illuminated e-stops. I know several of the folks on the calls have used these in different applications, and I think the customers end up being very, very happy with how those things look. So with the time we got left, I'm going to hit a couple other things that are out there. Is the distribution of safety systems is an ongoing thing. It's going to continue to be so, and it's going to give us a lot of flexibility in terms of how we mix and match stuff. So I'm going to take off my Banner hat and put on my Turk hat here. Turk has had these for a while, and in terms of vendor delivery issues, they've certainly been on our problem child list for a while, but hey, they've gotten a lot better. They're continuing to get better. And why can't see. But one of the things that they're doing is IP67 machine mountable safety stuff. So now we're doing safety bricks like these. So versus the Banner in cabinet, in rail type traditional relay form factor, these are hybrid safety modules. And then we also do these in a pure safety block. So if we were going to look at those, and I put a few of these documents in the chat if you're interested. Yeah, put this one in here as well. Open that one up. Go through this quick here to see. The biggest difference is with this type of hardware, these are designed to work specifically with safety PLCs. So a Siemens safety PLC, a Rockwell safety PLC, I believe Schneider's got them. I think the Asian manufacturers have them as well. The issue, generally speaking, with the high-level safety PLCs, they're very expensive. I did a quick Perplexity search, which is my go-to AI bot that Mr. Hodges turned me on to, and Regard Logic's PLC is like 28 grand. So to add a high-level safety function on a bigger PLC is significantly more expensive. That's one of the reasons the devices like the Banner controllers are so popular. It allows the customer to use their standard PLCs, do all this, offload all the safety to the safety controllers, and then be able to just have it communicate and tell, hey, the PLC what's going on, but everything's being handled downstream. These two blocks here for Turk, one is ProfiSafe, one is SIP Safety, so Rockwell, Schneider Siemens, and these are hybrid, which is a cool feature because we've got two safety inputs. We've got actually two safety outputs. So we could switch to like a VFD safe torque off in a remote drive panel over communications this way, whereas other ways of doing it would be much more wiring intensive. Standard input channels. So now what's cool with these is you're still actually have some capability for localized IO in conjunction with the safety, and two IO link master ports. So how that looks, and you've got your basically, these are going to be your OSSD inputs and outputs. So you get to be running light curtains, the stops we looked at, the RFID switches, scanners, other stuff. It's just your standard industrial safety input. The hybrids are cool because what you would run into is a lot of the safety blocks like this on the market are safety only. So you would have to have a block for the safety and a block for your standard IO next to it. With the hybrid stuff, so you'd have something that would look like this. Hybrid wise, we can do these and just space them out as they go and have your little IO and safety clusters as you go along the side of the machine. We do also make this as a full safety block, so all the IO is safety ins and outs, but they're still operating on SipSafe or PropiSafe. So again, you'd see traditionally a safety block, a non-safety block like that, which now would just be uh, a hybrid one to take up less space, less cost, less programming. We have a programming environment for this, and we are going to have a built-in safety controller into one of these blocks or these blocks. Sounds like Turk will have that this year. So now this would be able to also do on-machine safety program capability without a supervisory safety PLC. So more to come on that when it becomes available. Um, so yeah, you can just take all the advantage of all your various types of things. Here we're showing an e-stop in out to a safety valve out. Our software interface to map the devices around. So we still have the ability to do some local logic. But again, this is still being connected to a supervisory system. And those are readily available. Turk's got those in stock in Minnesota in both flavors. Well, actually, the hybrid blocks and the non-hybrid blocks are available. So we can easily get those things out and deployed. So the last thing I'm going to hit on in our remaining few minutes is one more thing that is coming out here. So this has been in the works for a while, and it is starting to finally appear in the world, is IO-Link safety. So IO-Link safety will probably be the next big thing in terms of taking advantage of that IO-Link architecture. We've done classes on IO-Link. I mean, basically the gist of it is a simplified low-level bus system to take your standard IO devices and end of the run sensors types of things and put them on a communication bus for better diagnostics, easier programming, all the various things that go with it. What you're going to see on the IO-Link safety is pretty much same behavior, and they're still going to be using 4-pin M12, but what they'll have then is your OSSD 1 and 2, and by using basically a communication, a pulse train, that's how they're going to be executing doing this. There are some of our competition out now that do have some IO-Link safety devices out there, but from what I can find as of right now, the offering is still pretty limited. Both Banner and Turk are addressing this. They're kind of taking their time, I guess, a little bit to figure out what makes the most sense and what to get out there. But I think you'll end up seeing, safety light curtains on IO-Link and things like that pretty quickly. I mean, this is over the next few years, this will become very popular. So really just want to make you guys aware of it. We don't have anything specifically in this space now, but those things are coming. And yeah, so I don't know if anybody's got any questions. We've got a few minutes left before we turn you loose. Feel free to chime in. I did put this Banner Safety Solutions brochure catalog here, which is very nice just for even the basic graphic overviews and how we can do different things depending on how we lay stuff out, and even being able to add in the cloud and the networking capabilities where, okay, now you could have a remote site and someone in a supervisory location elsewhere would be able to see what's going on with the safety system. They're not controlling anything, but they're able to view what's happening. So again, these are in the chat. You can grab them. And then I grabbed or added the Turk compact IP67 blocks.
Chad,
Chad,
could you?
Chad, just an FYI, I, for some reason, for this particular meeting, I've never been able to access the chat. I can in other meetings, but not this one. So, if you
Anybody else have that problem?
could send that out, that'd be helpful.
Yeah, we can just email that as a follow-up. Danny, if you're still here, can you get into the chat? You see it?
Actually, no, having trouble loading messages. Try refreshing.
Yeah,
same
that's
here.
the
Okay.
same thing I get.
I
All
don't
right.
see the
Well, we'll
chat
email them
either.
out and then we'll see if we can figure out what's causing that.
Would you also put the link to that excellent parts um, assembling page at Banner? And I'll
Sure.
send that out along with the stuff you've put on the chat.
Perfect.
And then I hate to blindside you with this question, but it only came up to me while you were talking about this, and this is a difficult question, so um, you're just foretold as forewarned. Allen Bradley, Siemens, and Beckhoff have relatively sophisticated network safety associated with their industrial controller products. And I think they're well done. It's also obviously an exclusionary tactic to their competitors like us. How do we address a customer who, for example, is using Allen Bradley network safety? Do we have the ability to integrate our components onto the Allen Bradley PLC safe networks, and thus compete with Allen Bradley's safety sensors and components, which for the most part are private labeled anyway?
Mm-hmm. Yeah, we could basically, that is, safety devices or the end devices when they're switching OSSDs or your standard safety outputs. They're pretty much universal. So we could, if they had guard logics and downstream safety blocks like these and wanted to use our e-stops with them, they should be able to do that. It just becomes a function of, we got to make sure the pinouts and everything are right, but that is certainly doable. We can deploy these. So these are specifically for that environment, which is they have an upstream safety PLC. They're running SIP safety around the network. And I can't remember what that stands for, but um, it is basically going to look just like a node, like any other Rockwell node on there by using our blocks. We don't have the ability to do that on Banner. They've been looking at adding SIP-Safe and Profi-Safe on the network side for remote panels. I'm not sure where that's at. I imagine we'll learn more in a few weeks when we have their kickoff meeting. And yeah, so I don't know, hopefully that answered your question, Pierce.
So SIP, which stands for Common Industrial Protocol, um, is that an Allen Bradley network?
Yes.
Oh, nice. So what about Siemens or Beckhoff?
So Siemens is Profi-Safe. We don't have any Beckhoff. I think that would fall under TwinCat. We don't have anything on either vendor as of right now that would natively speak on the Beckhoff network and have a safety capable communications.
And when you say that, you mean these IO sleds and any safety relays that we manufacture?
Yeah, so the Banner safety controller, these guys, we have an EtherCAT slice, but it's
Oh,
purely communication. It is not a safety slice, meaning we can't switch safety communications on that. It's purely to talk back to the PLC to say, hey, here's what we're doing. It's supervisory communication only.
so as a competitive strategy, then, would we be able to make a case for using the Banner safety controller with a, shall we say, advisory connection via Ethernet to the PLC, but then eliminate the SIP safe section of the Allen Bradley PLC um, to achieve total design on the machine? And would we be, I would imagine we'd be less expensive.
Yeah, that's absolutely our play and why. I mean, probably 95% of these things banners sold in the US are plugged into a ControlLogix or talking to a ControlLogix. The cost advantage is very significant. Like I had mentioned, I had popped in just because it's the quickest way to search stuff. Let's see where to go. Yeah, guard logics base level. I mean, this is fairly, kind of your ControlLogix equivalent. $21,000. Our safety controller, $600.
Oh my God. Are you kidding me?
And this, they couldn't even find a price for this one. Suffice it to say, it's more.
Wow. Okay. Yeah, well, that's a pretty significant argument. These safety controllers, on my experience, are relatively easy to learn how to program. You don't have to go to
Yeah,
Allen Bradley PLC school to do it.
yeah, exactly. I mean, our programming, the Banner programming software is free. The Turk programming software for the blocks, I don't think is free, but it's very inexpensive and it's kind of a one time, and you can program a million blocks with it, kind of like some of our other motion control software. So yeah, it's that is the advantage. It's just cost, and I would say you're dealing with people that probably understand the safety much more so than your average Rockwell sales individual who's not also the safety person.
Understood. Is most of the programming on the Banner safety controller object oriented?
Effectively, do we show it? Yeah, here we go. You're basically just picking what you're doing, getting your wiring IO. It builds out your functional diagram, builds your wiring diagram. So it literally tells you where to wire everything up. You can run this in simulation and live mode. So it's just fantastically simple software.
Okay. I should mention to the people on the class, and I'll certainly mention this in the email that I send out with the stuff Chad wants me to distribute, that we would be willing to teach a class on this programming to the specific audience that's interested. It probably is not a good thing for the 7 a.m. Monday morning class, but we could do a similar format here. I know I would be interested in um, learning how to program these devices. They're really quite simple, and then you get a lot of capability. So if you have interest, or if one of your colleagues would be interested in a class, just drop me a note and we can arrange something for you.
All right. Well, if there's any other questions or not, let us know. I've got a lot of experience in this space and usually can give you some pretty good ideas on different ways to do things. And yeah, the safety projects still end up being nice little, you know, financial wins, and our ability to interface with kind of everybody in the field. A little bit less so with Beckhoff, but that will improve more. Is always an ongoing thing. So by all means, reach out and let us know what we can do to help.
One last question before we part. At the OEM level, I've noticed that from a light curtain standpoint, the Keyence and some of the other competitors have been quite effective out here on the West Coast. How do we do against those companies with the Banner light curtain product?
We can compete. The new S4B family that Banner released is the competitive leader for us. So this is the family that would compete with your Keyence would be your biggest runners we'd see out here. This was
Right.
designed to compete on price. Yeah, light curtains go for pennies on the dollar from what they went for 20 years ago. And yeah, that just it is what it is, right? But we do these in 14 and 30 millimeter resolution. We do them up to 1800 millimeter length. We can daisy chain these and do cascade modes. We can do muting. Um, we don't need a computer to program this. The smarts are actually in the connector plug, and you just set them via dip switches. So there's some nice advantages here, and really, we launched this, and then we had lots of supply chain problems for a couple of years. That's not 100% mitigated, but certainly got a lot better. They've expanded the lines for this both in Minnesota and Mexico. So this is our light curtain solution. We still have other versions available, but you know, really, there's very little reason why I would go with any of these other ones other than S4B.
And S4B size-wise is close to the Keyence.
Yeah, it's almost exactly the same form factor with
The
the
Keyence is
recessed
still
lands.
the Keyence is still coming from Asia, right?
Yeah, I believe so. I don't think they manufacture anything here.
Okay, so that seems to me to be the Likert we run into the most at the OEM level. So for those of you that are in that market, when you find that type of opportunity, come talk to us about the S4B.
Yeah,
Yeah,
and we
Banner,
understand
Banner
what
has
the
gotten Banner has gotten really competitive price wise with Keyence. I've run into situations in Northern California and been able to Banner's not been as shy about lowering price on items, especially when competing with Keyence.
yeah, they know what the street price is, and they built this to compete. Our previous flagship product was this LS series. This thing is a tank. I don't know that you could break one of these. And it was just it was too expensive. I mean, I would only ever pick one of these for like the worst possible machine to put it on. But everything we can do really with any of the old traditional curtains we can do here. So reach out. We understand that, and one of the things we do really well is we'll bundle up the safety. If we can get it to revolve around our safety controller, we stand a very, very high level likelihood of winning. Keyence has a safety controller. It kind of stinks. Sick has lots of safety controllers, but it's German, so you can imagine how that goes. And really, some stuff from pills, other things like that. But our programming environment, our cost points, our flexibility is really second to none. And that's a big advantage for us. So once we get folks to use our safety controllers and our software, they're big fans. So it's pretty tough to get us out there.
Yeah, the Pills is the safety controller that used to be out private label by Allen Bradley, right?
I believe so. And I think they had some sort of agreement or one that they had with Omron as well that they were building. They've had many iterations of safety controllers.
Okay. Very good. Well, Chad, excellent session. Thank you very much. And thank you for allowing us to go 5 minutes over time, colleagues. It's 8:05. Time to go to work, and I will publish the schedule for the new year on the upcoming classes this week. So please look out for that. I will send the Turk and Banner PDFs out along with the link to that Banner site. And with that, have a great week. Happy New Year. And we'll see you next week.
Thank you.
Thank you.
Thank you, Piers
Appreciate it.
and Chad.
Thank you.
Thanks.
Thanks.